The what is programming slide? Yes? No, no one can see my screen yet. How about now? Now I can focus on my screen? Perfect. Okay, so this slide should look a little bit familiar because we talked about it on day one, but we figured it'd be a good time to just do a quick refresher. Day one, we talked about HTML. Day two, we talked about JavaScript. Oh, sorry, CSS. And they're both programming languages. Don't get us wrong, but they're more kind of visual. They're more for visuals. So they're more for designing the visual layout of a web page. Typically speaking, when people talk about software development and programming, what they really are referring to is kind of more higher level complex problem solving, right? So if I want to do any kind of heavy computation, if I want to manipulate data or transfer it in any way, that's where kind of more traditional programming comes in. And JavaScript is a language that enables us to do that in a very wide variety of ways. So not trying to take anything away from HTML and CSS here, but just as a forewarning, whereas before the past 2 days were more about visually, how do I make something that looks good? Now it's more about how do I actually solve a more complex problem. So what is programming? Once again, it's concerned with transforming input into output, and this will be an extremely applicable for what we're talking about today with JavaScript. It's definitely a very logical in decision making, and once again, when we're doing more complex problem solving, invariably that becomes a bigger part of the equation. Repetition, and it's also social and creative. The social and creativity part, hopefully you've already seen through HTML and CSS, but here's kind of where we really get into the realm of what's the best way to do this. Well, there's no best way, right? There are multiple good ways usually to solve a problem. And so the one thing that we want to start off by kind of warning you on with regards to programming and especially JavaScript is most folks think that programming is just you sitting at a keyboard and kind of banging out code, right? And a lot of code very quickly, and that makes you a good programmer. When in reality is if you ask any programmer who's actually done this for a while, they'll tell you that writing code in a lot of ways becomes the least difficult and not the easiest, but it's definitely not the most intensive part of the code. Whereas a programmer may spend 20% of the time writing code, they will spend a multiple of that testing code and then fixing all the issues that came up with their programs. And this is normal, it's true, and this is normal for both novice software programmers as well as advanced ones. And the reason why is because think of writing a novel, right? Like yes, if you're just learning English for the first time, yes, the vocabulary, like knowing the vocabulary words, knowing the syntax, knowing what to write, it's pretty difficult, right? Learning the rules of the language. But once you know English decently well and I ask you to write me the next great novel, well, what becomes harder is not the language part, or it's the idea, it's the clarity of thinking. It's the is my novel actually telling the story or is my novel actually telling a compelling story? And it's the same exact thing with programming too, where in the beginning, yes, the syntax and the vocabulary are going to be difficult, but the more you program, the more that becomes second nature to you. What becomes more difficult at that point then is if I'm being asked to solve a complex problem, am I actually thinking about the problem correctly? Do I have a logical answer in mind, and then can translate that into the code in a way that is safe and effective? So as a general rule of thumb, people spend much more of the time testing and debugging code than they do writing new code. And my biggest piece of advice to people who are first starting off is before you write any program, before you start coding anything, always make sure that you understand what the problem is, and then you understand how you're going to solve it. Jumping in and solving a problem without knowing what you're going to do is kind of like, and I might have given this analogy to you guys before, but it's kind of like trying to build a house by just picking a piece of wood and then nailing it to another random piece of wood and hoping that by the end of this process you have a house at some point, right? It's like trying to do something without any kind of guides or blueprints, right? It just doesn't quite make sense. And it's the same thing with writing code too. Whenever you see a problem, before I know the gut instinct or the intuition to say, great, let me just start writing code. More often than not, what happens is without thinking through your solution clearly beforehand, folks start writing code. That kind of it actually starts dragging them down a little bit. They read their own code, they become more confused, and then it kind of devolves very quickly from there. So the clarity of thinking is by far the most important skill that you will need to develop as a software programmer, right? Ultimately, all software programmers know a language decently well. The ones that really set the good ones apart are the ones who can actually think through and solve problems. And really, that's kind of the value that any good developer brings to the table. So with that in mind, before we even kind of dive into the JavaScript language itself, one helpful kind of guide that we wanted to talk about is this idea of pseudocode. As the name indicates, pseudocode is not quite real code, but what it does is it actually gives you, it actually is just like a handful, it's a handy way for you to start thinking about framing and verbalizing the solutions that you want to solve, right? So basically what pseudocode does is it really pushes you on the two boundaries of defining what the purpose of this program or this piece of code is, and then two is how will this program or code be structured. So for example, if I say I want a program that texts me before I leave for work to see if there's a chance of rain, or if I want to create a program that sends an automated email to my family members on a given time of the week, right? These are all problems that when I describe them to you, to a human being, they're like, yeah, it makes sense. But if you really think about how you want to solve them, you'll realize it actually gets very complex very quickly. And before we start writing code, we actually need to draw up a diagram or a plan for how we want to get there. So that kind of brings us back to the idea of what is pseudocode. Essentially, it's an informal set of instructions that describes how a program or how a function is supposed to operate in theory in simple English, right? Another way to think about pseudocode is if I asked you to do, if you had to explain a task to a 3-year-old, how would you do it, right? And 3-year-olds aren't dumb, right? It's not a matter of intelligence, it's a matter of context, right? Going back to something I brought up on day one, if I tell you, or rather, if someone tells you or you tell someone else to say, hey, just Google it, right? Like that is kind of nowadays, it's a very common thing to say, and people understand when you say just Google it, what all of that entails. But if you were to tell a 3-year-old just Google it, well, actually, they sound like they don't know what to do. It's just they lack the context for understanding that means going to a computer, opening a browser, typing in Google, and then searching, right? And so pseudocode kind of helps us break down that very high level request, just Google it, into the more individual steps. So if I took an example of pseudocode, for example, if I had a robot that wanted to make me coffee, well, how would I actually tell the robot to make coffee? If this is a human being, and I wanted this person to make coffee for me, I would just say, hey, can you grab me some coffee, or can you make me some coffee? But to a robot, that makes no sense, right? So instead, what I actually have to tell the robot is a series of things. The first one is find the coffee maker. Step 2, fill the coffee pot with water. 3, pour the water from the pot into the coffee maker. Find the coffee filters. Put the filter in the coffee maker. Find the coffee grinds. Measure the coffee grinds. Put the coffee grinds in a coffee maker. Put the pot in the coffee maker. And then last but not least, click the brew coffee button and then bring the coffee over to me, right? And so that simple request of, hey, can you make some coffee for me, that I would give to another human being, if I had translated that to a robot, to a computer, or to a 3-year-old without context, it now becomes at least 10 steps. And notice how for any of these 10 steps, I could also break that down into a lot more steps too, right? And so with pseudocode, the point is not to kind of trap yourself into being so minutia and in detail that you kind of get lost in solving the problem. What it does kind of allow you to do is at least kind of break out this very large problem into smaller bite-sized chunks that then we can start working, right? That we can start working on. And so if I want to build a robot that made me coffee, I would actually say, okay, great, making coffee takes these 10 steps. Now let me start writing up the functions or the abilities for each of these 10 steps within the robot. Okay, so it's more of a tool than anything else, and we really strongly encourage you to use it. And throughout the next couple of days, whenever we're working through a problem and you say, hey, I'm stuck, or hey, I don't know how this works, what I'll always ask you is, great, tell me what you're trying to do, right? And when I say that, what I'm really asking for you is walk me through your thought process. How did you want the code to work? And then we can actually start kind of comparing line by line and see, is the code actually doing what you're planning for it to do? And so an example of pseudocode, for example, would be if I want this robot to clean up these 4 squares. Let's say these 4 squares are all dirty. How do I do it? Well, I would actually have the robot. I would basically give the robot the same set of commands and have the robot execute these commands over and over again for each turn or each square that it goes in. And what are the commands? The first one is clean the current square you're in. The second command is look at the possible moves we can make. 3 is if any of the other moves leads to a dirty area, then go to that area and then clean that room. Oh, sorry. If any of those squares are dirty, then move to that box. If multiple squares are dirty, then just pick one at random. And then lastly, when there's no dirty areas to move into, that means that we've cleaned up the entire room. And so if I take a look at this robot now, I am starting on my first step and I say clean the current square. So I do. The next step says check any possible squares I can move into. And now I can see that there are 2 dirty squares I can move into. So I pick one at random and I pick the one at the top. I move in there now. Now I move to the dirty area and I go back to my first step, which is let's clean that square. And then let's check to see if there are any possible moves. There's another possible move right there in which that square is dirty. I go into that square, go back to step 1, I clean it, I look for moves, I find one more square, I clean it, and now my robot is done because I've cleaned the current square. There's no more possible moves to go to because I've covered all the squares, and then I'm finished, right? And so once again, this kind of goes back to the idea of if I told this robot, hey, can you clean all the rooms? The robot's kind of stuck. It's like, what do I do? But if I break it down into these 4 repeatable steps, notice how now so now the robot is actually able to kind of go through and execute this on each square individually and eventually clean the entire room. So any questions so far on what I've talked about? I know so far a lot of it has been conceptual, and the next few slides will actually be more historical than anything else. But just want to pause and see if there's any questions before I go any further. Okay. So the next thing that we're talking about is actually the JavaScript language itself, right? Which, going back to our system of HTML being the skeleton and CSS being the skin, then the JavaScript is the brain or the nervous system of this web body. So we're gonna talk about the different. So today the JavaScript section is broken up across 3 days. Today we're actually going to cover very, very basic things, and if you've seen JavaScript or have done JavaScript before, it might seem almost too basic, and that's kind of by design. Our goal here is to kind of get everyone up to the same level, and so today we're going to talk about the history of JavaScript, programming languages in general, and then we're going to talk about the basic data types of JavaScript. On the next class, which is the following Monday, we're going to talk about loops, errors, etc., and then on the very last 3rd day of the JavaScript curriculum, we're going to talk about functions and objects. So we're going to learn about today specifically, we're going to talk about the kinds of data the JavaScript can handle, and then how to store that data and use that data for later. So before we go any further, just a really, really quick primer on JavaScript. Honestly, this is just kind of more contextual information for you to know what you're dealing with. I very doubt anyone will actually ask you this kind of in the real world. But essentially, JavaScript was created for Netscape. At this point, 25-ish, almost 25 years ago. And so when JavaScript was first released, it was meant to be a language that was used in the web browser. Nowadays, JavaScript is actually not just a static thing, and what that means is that the JavaScript that was being used 20 years ago is actually somewhat different than the JavaScript that's being used today. There's an organization called ECMA, and they're the governing body for JavaScript. They're the folks who decide what the JavaScript language looks like. And the best part is they're actually continually updating JavaScript too. And so what that means is every couple of years they'll release new features for JavaScript, they'll add new features, they'll improve security, they'll improve performance. And essentially like when we think about programming languages, don't fall in the trap of thinking, oh, this language is the same as it was, even a few years ago, because languages are always changing. And because of that, it's actually very important for a developer to always be staying kind of on top of the latest trends in the language of their choice. JavaScript is not only very old; it's actually also very popular too. And so, based on some Stack Overflow surveys, JavaScript is still one of the most populated languages out there. Regardless of whether that is the most popular or 2 or 3, the point still stands. There's a lot of JavaScript being used in the world, and that also means for us that there's a lot of companies who want to hire JavaScript developers in the world too. The reason why JavaScript is so popular is because JavaScript is a language that can be used across the entire stack. So what do I mean by the entire stack? Let's use Facebook as an example. When we think about Facebook, right, there's a part of Facebook that you or I see when we log in, right, and it's our profile photo, it's our news feed, the ads, everything, our friends' photos, etc. That's what we call the front end. That's the part that's facing the user, right? And so JavaScript is a language that can kind of create that interface. And we know that because we've already done it, right? We've made HTML, we've used CSS, and it's not impossible to see us being able to create, a page that looks something like a Facebook homepage. Um, However, there's also the back end of Facebook, right? There's also the sides of Facebook that you don't see, and so these are things like the friend graphs, how they think about processing their information, how they make requests, how they handle user behavior, and all these things. And so those are the parts of the website that the user doesn't see, and so usually that's called the back end. And JavaScript as a language is unique because whereas we can use the language to write the front end, the client-facing part of the web, the site, we can also use JavaScript to write the back end of the site as well. And indeed, JavaScript can even be used to help manipulate and manage some of the database storages for a site as well. What does all of this mean? This means that JavaScript is one of the few, if not the only language that you can use to build an entire website from start to finish. And so, that makes JavaScript very, very powerful for people to use, and but it also makes it also means that it's actually very great for beginners for us to learn JavaScript too, because the idea is that if JavaScript works everywhere in both the front end as well as the back end of the code, then that means that you can just learn JavaScript, and no matter which part of the website or which part of the web development process you want to specialize in, you don't need to switch languages. A common question I get asked at this point is, well, what's the point of having so many languages then, right? And that kind of begs the question, well, why do we have so many types of cars or cereal or anything, right? All cars are four wheels and an engine, so why do we have so many kinds? And the quick and dirty answer is just because programming languages, like anything else, are subject due to, performance differences. All languages have their own strengths and weaknesses. People like some over others. And so there's no really, don't kind of get trapped in the idea of what is the best language to learn. Just know that at this point, we're teaching you what we're going to be covering in this curriculum and also in the full-stack curriculum. Everything that we learn is very transferable. As in, if you know how a loop and a function works in JavaScript, you will pretty much know how a loop and a function works in almost any other major language, right? And so don't get too hung up on why JavaScript as a particular language. Just think of it as we want to learn all of these programming concepts, and JavaScript is just the language that we're happy to use because it's one of the most flexible languages out there. Okay, so that was my kind of rushed introduction to JavaScript. It's rushed because it's kind of a nice FYI, but it doesn't necessarily kind of help us become better programmers. But I just want to pause again to see if there's any questions on anything that I've said. Okay, if there are no questions, let's actually jump into the meat of JavaScript, right? So the first thing we'll do when talking about JavaScript is we have to talk about data types. With HTML, there really wasn't. With CSS, we definitely didn't really deal with data types, and even with HTML, we didn't really deal with data types. Data types are basically just pieces of information that are stored in different ways. You can make an argument that the different tags in HTML are kind of like different data types, but the truth is we treat them all pretty much the same, right? We use them differently, yes, but we treat them pretty much the same. And with data types in JavaScript, it's a little bit more nuanced because the type of data that you're dealing with is actually very important because that tells us, one, what information you're trying to convey, and also two, what you're trying to do with the information. And so one distinction to just draw out right away is terms that are values and variables, which are terms that actually most developers use interchangeably, even though they actually mean something very different or somewhat different. The values essentially are data types that have a very specific purpose and a very specific behavior. And so when we think about values, right, we're thinking of things like numbers and strings and booleans and all these things. And I'll cover the list of them in a little bit, but just know that values are the actual value. Okay, so if you look on the right hand side, that first line, var space num of states equals the number 50 semicolon, that's a statement, and that's us creating something that's used to capture the value of 50. So then the next part is what is a variable then? A variable is simply an identifier or a label for a value. Okay, it's a reference to the value. It's not the value itself, if that makes any sense. So when we look at the first line here, var num of states equals 50, that's us saying we're going to create a variable. That variable is going to be called num of states, and it's going to represent the value 50. Okay, so 50 is a value, but num of states is the variable, right? It's like when we did basic math in, like, let's say high school, right? We always say, the x equals 6, right? 6 is a value, but wherever we use 6, we're going to use the variable x to represent that value instead. And very much like math, one of the reasons why we use variables is because we want to represent a value, but that value could also change, right? X could be different things at different junctures, and the same thing with variables too. Right now, we want the variable num of states to equal 50. That variable could also point to a new value if we ever decide we want to set num of states to something else. Similarly, in the second example, var name equals George, that's us saying, hey, let's create a variable called name, and let's have that represent the value of George, which is a string. And similarly, on the third example, we're creating a variable called answer, and that's representing the value of false, which is a Boolean, and we'll talk about that in one hot second. Okay, so with regards to variables, just know that they have a few rules around their naming convention. One is they cannot contain spaces. Two is they must be given with a letter, underscore, or a dollar sign. And then they can only contain numbers, underscores, letters, or dollar signs. And last but not least, variables are also case sensitive. That means if I have a variable called name, all lowercase, and then I have a variable called name with the e being uppercase, JavaScript will treat that as two distinct variables. And lastly, variables cannot be a reserved keyword. What does a reserved keyword mean? Or sorry, what is a reserved keyword? Essentially, that's a word that's actually a part of the JavaScript language. And so we actually see an example of that on the right-hand side right now. When I want to create a new variable, I use this var keyword, right? And notice how in most code editors nowadays, whenever you type in a reserved word, it will show it in a different color. In this case, the var shows up as like a darker blue, right? What that means is I cannot have a variable I cannot have a variable called var. Why? Because var, whenever JavaScript sees the letters var together, it knows that I'm asking it to create a new variable, right? That means that var cannot be a variable in of itself. And we'll see a few other reserved keywords throughout the course of this section as well. Usually, if you try to create a variable with a reserved keyword, something in your editor will actually just throw an error and tell you, hey, like you can't do that. Please pick another variable name, essentially. And then last but not least, and this is something that we just want you to be aware of, but we're not going to talk too much in depth. You can create a variable through multiple keywords. You can use var, so we can say var name equals George, or we can say let name equals George. There is some performance differences between the two, but we don't want you to get kind of too hung up on that now. Just know that there are multiple ways to create variables, but for the rest of the examples in this section, we'll be using var. Okay, so without much further ado, here are the different data types. There's a lot, right? And I wouldn't stress too much about trying to memorize it right now, simply because in the workshops, as you go through them, you'll be doing some exercises with each one of these types. The two main buckets in which JavaScript data types are being divided into are primitive and objects. And we won't talk too much about the difference between the two, but just know that there is that categorization. And so let's just dive into the most common ones. The most common data type that we're going to come across is going to be numbers. Numbers, I mean, hopefully I don't have to explain numbers to folks, but the numbers in JavaScript work very much the same way that numbers in basic primitive math works in anywhere, right? So we can use numbers to do arithmetic operations. We can use it to do calculations, and last but not, but actually I guess most importantly, when we do use numbers, just note that numbers we can do math with, right? We can do math with other data types, and so you might see us try to use mathematical operations with other data types, but just know that it's not arithmetic in the way that we traditionally think about math. Okay. And so yeah, so the first data type is a number, and the numbers are exactly what you see here. JavaScript doesn't require anything extra for you to do really big numbers. You can write really big numbers, you can write decimals, you can write negative numbers. Everything's fair game. So it's a pretty flexible system there. The next data type we're talking about is strings, which are essentially a series of characters that are enclosed by either a single quote or a double quote. If you look in the code snippet on the bottom there, we have two strings. The first one, we're creating a variable called full stack, and the value of that full stack variable is this string full stack in light blue with a capital F. And then beneath it, we create a variable called academy, and the value of that string is the string academy with a space before it. One common thing that you often see with regards to people changing strings is they'll just add two strings together, right? And it's kind of harkens back to what I said on the previous slide. That's not really arithmetic. In this case, that's called concatenation. And if you can think of us as adding two strings together, as pretty much just kind of shoving two strings together, one behind the other. And so that's kind of what we do when we think about adding strings together. Yeah, so even though we say we're adding strings together, just know that it's not an arithmetic operation. And then every string that we've ever seen, if you just put dot length after it, that will tell you the number of characters in the string. And if you have an empty string, then it will give you back 0 to tell you that there's no characters in the string. In any case, the point here is for you to know that whenever you use dot length on the string, you are guaranteed to get back a number, even if that number is 0. And then last, and this is hopefully the most simple data type that you're going to see today, right? It's something called a Boolean value. A Boolean is a binary data type with only two possible values, true or false. Remember on day one, I talked about how computers are very, very good with kind of very logical, very precise decision making. Well, it doesn't get any more simpler or precise than a Boolean, right? There's only two possible options, either true or false. It's either a go or a no-go. And so Booleans are actually very common in programming and computer science in general because of how simple it is and how it really makes the computer, or the human in this case, kind of pick to see, is this true or is this false, right? And so it reduces almost all the room for ambiguity, and it's something that you will see quite a bit of too going forward. Last but not least, the last two primitive data types we'll take a look at are nulls and undefineds. I wouldn't worry too much about these for now, and that's just because undefineds and nulls are, you see them, but you likely won't use them intentionally, at least not until we kind of touch on more advanced topics. But as a quick primer, what undefined means is it's saying, hey, this variable does not have a value yet. And whereas null means, hey, this variable has no value. Like I've already explicitly said, this thing has no value. So it's a very slight nuance. I wouldn't worry, once again, I wouldn't worry too much about it here, but just know that these are also data types that you're going to come across in JavaScript. Okay. Now we're going to go to some of the more advanced data types. The first one is an array. In Python, which is another programming language, arrays are actually called lists, which I think are actually a great way to think about what arrays do. Arrays basically contain lists. The beginning of the array is the opening bracket, which we see on the far left there, with a nice little arrow pointing to it. It's a list. The beginning of the list starts with that opening bracket. Every item in this list then is separated by a comma, which we see here. And then when the list is over, we put a closing bracket there to indicate that that's the end of the list. And so in this case, we made an array or a list with 4 possible values separated by 3 commas. The first value is a true, which is a Boolean. The second value is true with quotes around it, which tells us that it's a string. The third value is false, which is another Boolean. And the last value is 22, which is a number, right? And so this also kind of brings up the idea that arrays in JavaScript, you can put anything in there. It can be ultra flexible. You can even put other arrays in there too, which we'll talk about later on. But the idea is that you don't have to store only items with the same data type. You can mix and match as many different types and as many different data points as you want. Yep. So arrays are just basically JavaScript's handy way of doing lists. Contrast that with something called objects in JavaScript, which are a combination of properties and values, or what we call key and values, or pair together key value pairs. In Python, we actually call objects dictionaries, which I actually really like, because in the way that the object in the way that an object is just a collection of keys and values, we can actually say a dictionary really is just a collection of words and their definitions, right? And so whenever we want to access a definition in a dictionary, we look it up by the word. Similarly, in JavaScript objects, whenever we want to access the value for an object, we look it up by the property. Now, we're going to do a much more in-depth lesson on objects on next Tuesday. So right now, we're just trying to let you know that objects exist. You won't be dealing with it in today's workshop, I don't think, but we will be touching on objects definitely in more depth next week. And we will also be talking about this next thing in more depth as well, which are functions. Functions are basically just reusable pieces of code. It's similar to a recipe in the sense that whenever you have a function, your goal is to run this function over and over and over again, right? It's something that you can actually reuse many times to do the same thing, right? In the same way that a recipe has the same steps, and really multiple people just take a look at that recipe and they execute on that recipe. And so here, I'm not going to go into too much depth once again, just because we'll be doing another session on functions on the next Tuesday. But a function basically provides a lot of steps. And in a lot of ways, functions are essentially, if you remember in the very beginning of this lecture, we talked about pseudocode and having those multiple steps. Functions are essentially just ways to kind of take each of those steps and translate it into an action that a computer or a program can take. And then last but not least, we're just going to finish with our old friend comments. Not a data type per se, but they're something. JavaScript has two ways to write comments. You can either write a single line comment with two backslashes, the way we see on the first line and also at the end of the second line, or we can write a multi-line comment, which we see on lines, I guess, 4 through 6 there. And the syntax for a multi-line comment in JavaScript is the same as it is in CSS, which is \**, and you close it off with an *\\. Was there a question? I think I heard someone unmute their mic. Okay, guess not. Yeah, so that was a lot of information coming at you all at once. But I think the workshops, as you work on each data type individually, it'll make a lot more sense, kind of how they're used, and you kind of see it in action. Today inside, so whereas before we had to use CodePen, today we'll use them called RunKit. Don't worry about what RunKit is, just know that it's a place where you can write JavaScript code and it will run JavaScript code for you. That's the extent of our involvement with RunKit, so don't let that throw you off. But yeah, are there any questions around anything that I've talked about so far?